Hi, my name is John Calvin, and I'm a datacom planner with Keysight Technologies. This video will offer a short introduction of Keysight's newest optical accessories, as well as software designed for Infiniium UXR-Series Real Time oscilloscopes, directed to validation and debug support and standards. 800 gig research is well underway, and alternate modulation methods are at the forefront of higher speed signaling schemes. Whether the industry settle on 96 gigabaud PAM6 or 112 gigabaud PAM4, there is a uniform set of problems that the combination of a Infiniium UXR-Series Real Time oscilloscope and the N705A ODE converter solve uniquely well. In the field of clock recovery, having flexibility based on single-shot acquisition and signal processing is central to the real-time instrument value proposition. Conventional physical limitations in clock recovery rate support and fidelity are completely sidestepped in this architecture with an Infiniium UXR series oscilloscope. Core optical measurement capabilities with the same intuitive user experience and operation of a DCA make result accuracy and consistency across the real-time and equivalent time architectures a reality with the FlexRT software interface connected to the Infiniium UXR oscilloscope. In this FlexRT demo, we'll start off by making a remote network connection to the Infiniium UXR series oscilloscope that has the N705A ODE converter attached to an EML-based 1310 nanometer optical transmitter emitting SSPRQ pattern. Once we connect, we immediately see the unequalized raw optical signal on channel 1A in this case. We have a vertical histogram set up on the raw input, and a few statistical results from the histogram are visible here in the lower left-hand part of the measurement display area. Meanwhile, the TDECQ and CEQ measurements are running through an adaptive 5-tap FFE optimization process, and once completed, we'll see the resulting TDECQ reference equalized output and its derived results on the right-hand side of the display. Leaving the instruments on free run, we can iterate on this set of conditions and repeat these measurements, taking about 4 seconds per iteration. Here we will just run a couple of cycles of the FlexRT measurement system to underscore the speed and versatility of these measurements in supporting the N705A. You may notice on the left side the PAM measurement tab, which has several measurement selections relevant to optical TX characterization available. The next set of capabilities on the N705A work in concert with the Infiniium UXR equalization and symbol error rate measurement systems. Here we have the flexibility to configure precise equalization capabilities and then to make system-level error trade-offs to hit prescribed target error rates without over-designing the system. The cost of too many taps comes in many forms, ranging from high power consumption concerns to real estate issues. Here we are reducing the number of feed-forward equalization taps to the point where our error rate starts to increase. We then localize precise PAM4 symbol where the failure is occurring and make intelligent equalizer configuration choices to advance the design to work around that single point of failure. This is a similar 53 gigabaud optical demo to the last TDECQ demo. However, here we're using the Infiniium UXR series oscilloscope capabilities to measure symbol error rate and to localize precise location and burst of consecutive errors within a specified block size. We start out with an unequalized signal with a symbol error rate of around 2.3 e to the minus 6, which is apparent with the SCR measurement result on the lower left-hand part of the screen. The limit test system can be used with the symbol error rate measurement to look for burst errors. The fail count in range, with a count of 2, 5,000 in the range field, will search for any case where there are 2 or more errors in any 500 contiguous PAM4 symbols. The limit test can identify multiple instances of burst error conditions in a single long record and navigate between them, or it can be used in a stop on failure to acquire continuously until such a burst is found. Once the limit test is properly set up, we can find a set of range count error conditions and have a marker pole set up to represent the delta between the expected gray-coded symbol and what was actually observed. We can easily search and index into these error conditions and observe them while we modify the equalizer states to address these single points of failure. Another way a designer can examine the error location and time relative to the start of a test pattern is to configure a horizontal histogram over the error distribution, which will clearly map the points of deterministic and random error locations in the pattern. Again, this is an ideal opportunity to increase equalizer complexity in a prescribed manner if the observed error rate is too high. Conversely, it offers an analytical means of dialing back an overly complex equalizer if it's exceeding the error rate requirements for a link. This concludes the summary of Keysight's new N705A optical to electrical converter module for use with Infiniium UXR-Series Real Time oscilloscopes. This brings 4 channels of time-synchronized acquisition to this traditionally equivalent time world of optical measurements. The combination of the N705A and the UXR series low noise makes this technology introduction a uniquely valuable tool set for 800 gig optical research requiring optical error detection, advanced equalization, clock recovery, as well as the capabilities of conventional optical measurements such as TDECQ. We at Keysight would be happy to discuss your optical measurement requirements here as you work towards 800 gig, be they real-time scope-based or equivalent time scope-based. If you need additional assistance with demoing one of these products or additional technical information, reach out to your Keysight field engineer and they'd be happy to help you. Thank you very much for listening and have a great day. Goodbye.